Okay, good morning. So we are discussing about the FIR filters. FIR means finite number of input to unit impulse response filters. Okay, finite number of unit impulse response filters. What do you mean by IAR filter? Infinite number of unit impulse response filter. Okay. Now we are going to discuss about the frequency response of linear phase filter FIR filter when impulse response is symmetrical and n is odd. Okay, let n which of n be the impulse response of the system. The frequency response of the system h of omega is given by okay h of omega equal to h of e power j omega, that is equal to sigma n equal to minus infinity infinity h of n into e power minus j omega n frequency response, or it is nothing but Fourier transform. Okay, so h of n into e power minus j omega n, or we can write this as sigma n equal to 0 to infinity h of n into e power minus j omega n. Okay, when n is odd here, when n is odd, h of n is symmetry, center of symmetry is at n minus 1. Okay, so it can be written as a sigma n equal to 0 to n minus 3 by 2 into h of n into e power minus j omega n plus h of n minus 1 by 2 into e power minus of j omega. Instead of n, we replace n minus 1 by 2 plus sigma n equal to n plus 1 by 2 to n minus 1 into h of n into e power minus j omega n. Here m equal to n minus 1 minus n. So that let m equal to n minus 1 minus n, so that n will become n minus 1 minus n. And small n equal to n plus 1 by 2. So m will become n minus 1 minus n plus 1 by 2. Okay, n plus 1 by 2. If small n is n minus 1, then it will become n minus 1 minus n minus 1, that is 0. So h of omega equal to sigma n equal to 0 to n minus 3 by 2 into h of n into e power minus j omega plus h of n minus 1 by 2 into e power minus j omega into n minus 1 by 2 plus sigma n equal to 0 to n minus 3 by 2 into h of n minus 1 minus m into e power minus j omega n minus 1 minus m. Put m equal to n. Replace n by m. Then it will become sigma n equal to 0 to n minus 3 by 2 h of n into e power minus j omega n plus h of n minus 1 by 2 into e power minus j into n minus 1 by 2 plus sigma n equal to 0 to n minus 3 by 2 into h of n minus m is replaced by n. So h of n minus 1 minus n into e power minus j omega n minus 1 minus n. So that it will become sigma n equal to 0 to n minus 3 by 2 into h of n into e power minus j omega n plus h of n minus 1 by 2 into e power minus j omega n minus 1 by 2 plus sigma n equal to 0 to n minus 3 by 2 into h of n into so n minus 1 minus n can be replaced by n, so that this is h of n into e power minus j omega into n minus 1 minus n. Okay, so taking e power minus j omega into n minus 1 by 2 as common. Okay, so this is h of n minus 1 by 2 plus sigma n equal to 0 to n minus 3 h of n into e power minus j omega n into e power minus j omega n by n minus 1 by 2 plus sigma n equal to 0 to n minus 3 by 2 into h of n into e power minus j omega n minus 1 by n into e power j omega n minus 1 by 2. Okay, so so that it will become e power minus j omega n minus 1 by 2 into h of n minus 1 by 2 plus sigma n equal 0 to n by 3 minus 2 h of n into h of n is taken as common. So e power j omega n minus 1 by 2 minus 1 plus e power minus j omega n minus 1 minus n minus 1 by 2. Okay, so this will become e power minus j omega n minus 1 by 2 into h of n minus 1 by 2 plus sigma n equal 0 to n minus 3 by 2 into h of n into e power j omega n minus 1 by 2 minus n plus e power minus j omega into n minus 1 by 2 minus n. Okay, so is equal to e power minus j omega n minus 1 by 2 into h of n minus 1 by 2 plus sigma n equal 0 to n minus 3 by 2 into h of n into 2 cos omega n minus 1 by 2 minus n. Okay, let k equal to n minus 1 by 2 minus n and n equal to n minus 1 by 2 minus k. Okay, so n equal to 0. If n is 0, then k will become n minus 1 by 2. If n is n minus 3 by 2, then k will become n minus 1 by 2 minus n minus 3 by 2. So it is n minus 1 minus n plus 3 by 2. N gets cancelled. 3 minus 1, 2 by 2, that is 1. So it is equal to e power minus j omega into n minus 1 by 2 into h of n minus 1 by 2 plus sigma k equal to 1 to n minus 1 by 2 into 2 into h of n minus 1 by 2 minus k into cos omega. So put k equal to n, so that h of omega will become e power minus j omega n minus 1 by 2 into h of n minus 1 by 2 plus sigma n equal 1 to n minus 1 by 2 into 2 into h of n minus 1 by 2 minus replace k by n, so minus n into cos omega by n. So the magnitude function of h of omega is given by mod h of omega is equal to h of n minus 1 by 2 plus sigma n equal 1 to n minus 1 by 2 into 2 into h of n minus 1 by 2 minus n into cos omega n. And the phase function of h of omega, angle of h of omega is given by minus omega into n minus 1 by 2. Okay, minus omega into n minus 1 by 2. So this can be written as minus omega into infinity or omega into alpha. So this is about the magnitude and phase representations for this case. Okay, so then impulse response is symmetrical and n is r. Okay, then the next case is frequency response of linear phase FIR filter. An impulse response is symmetrical and n is even. So for the previous case, if n is odd, what will be the situation? So if n is even, then we'll go through this. So frequency response of linear phase FIR filter with impulse response h of n and n samples. H of omega equal to h of e power j omega, that is sigma n equal 0 to n minus 1 h of n into e power minus j omega n. Okay, for symmetric impulse response with even number of samples, the center of symmetry lies between n equal to n minus 1 by 2 and n equal to n by 2. N is in between n minus 1 by 2 and n by 2. Okay, then h of omega is expressed as h of omega equals sigma n equal to 0 to n by 2 minus 1 into h of n into e power minus j omega plus sigma n equal to n by 2 to n minus 1 into h of n into e power minus j omega n. Let m equal to n minus 1 minus n, or n will become n minus 1 minus m. So h of omega for n equal to n by 2. Okay, this will become m is n by n minus 1 minus n by 2, that is n by n minus 2 by 2, that is n by 2 minus 1. And if n equal to n minus 1, then m will become n minus 1 minus n plus 1, so that it will become 0. So h of omega equals sigma n equal to 0 to n by 2 minus 1 h of n e power minus j omega n plus sigma n equal to 0 to n by 2 minus 1 h of n minus 1 minus m into e power minus j omega n minus 1 minus m. Put m equal to 1, then it will become sigma n equal to 0 to n by 2 minus 1 h of n into e power minus j omega n plus sigma n equal to 0 to n by 2 minus 1 h of n minus 1 minus n, okay, into e power minus j omega n minus 1 minus n. Okay. So the impulse response is symmetric h of n minus 1 minus n. So this is equal to h of n. So that h of omega will become sigma n equal to 0 to n by 2 minus 1 into h of n into e power minus j omega n plus sigma n equal to 0 to n by 2 minus 1 h of n into e power minus j omega n minus 1 minus n. So taking e power minus j omega into n minus 1 by 2 is common. So this is sigma n equal to 0 to n by 2 minus 1 h of n into e power minus j omega n into e power j omega n minus 1 by 2 plus sigma n equal to 0 to n by 2 minus 1 h of n into e power minus j omega n minus 1 minus n into e power j omega n minus 1 by 2. Okay, so this will become e power minus j omega n minus 1 by 2 into sigma n equal to 0 to n by 2 minus 1. H of n will be taken as common. So h of n into e power j omega into n by 2, n by 1 minus 2 minus n plus e power minus j omega into n minus 1 minus n minus n minus 1 by 2. Okay, so e power minus j omega n minus 1 by 2 into sigma n equal to 0 to n by 2 minus 1 into h of n into e power j omega n minus 1 by 2 minus n plus e power minus j omega, and this will be simplified as n by n minus 1 by 2 minus n. Okay, so that is equal to e power minus j omega n minus 1 by 2 into sigma n equal to 0 to n by 2 minus 1 into h of n into this is nothing but e power j theta plus e power minus j theta, that is 2 cos omega into n minus 1 by 2 minus m. Okay, so it is e power minus j omega n minus 1 by 2 into sigma n equal to 0 to n by 2 minus 1 into h of n into 2 cos n by 2 minus n minus 1 by 2. Let k equal to n by 2 minus n. Okay, so then n will become n by 2 minus k. If n is 0, then k will become n by 2. If n is n by 2 minus 1, that is n by 2 minus n by 2 plus 1, so it will become 1. So k equal to n, then h of omega will become e power j omega n minus 1 by 2 sigma n equal to 1 to n by 2 h of n by 2 minus n into 2 cos omega into n minus 1 by 2. Okay, this can be written as sigma n equal 0 to n by 2 2 into h of n by 2 minus n into cos omega into n minus 1 by 2. So that is magnitude, and phase angle is minus omega into n minus 1 by 2. That is minus omega into alpha, where alpha is n minus 1 by 2. So, that is an n is even and symmetric. The magnitude and phase angles are like that. Next case is frequency response of linear phase filter when impulse response is anti-symmetric and n is anti-symmetric. Okay, so frequency response linear phase FIR filter with impulse response h of n of n samples h of omega is equal to h of e of j omega. So P sigma n equal to 0 to n minus 1 h of n into e power minus j omega n. Okay, h of n into e power minus j omega n. For anti-symmetric impulse response with n odd samples, the center of symmetry is at n minus 1 by 2. Okay, then h of omega equals sigma n equal 0 to n minus 1 by 2 h of n into e power minus j omega n plus h of n minus 1 by 2 into e power minus j omega n minus 1 by 2 plus sigma n equal to n plus 1 by 2 to n minus 1 h of n into e power minus j omega n, right? Okay, if the impulse response is anti-symmetric, then h of n minus 1 by 2 will become 0. So then h of omega will become sigma n equal 0 to n minus 3 by 2 into h of n into e power minus j omega n plus sigma n equal to n plus 1 by 2 to n minus 1 h of n into e power minus j omega. Since h of n minus 1 by 2 will become 0, that's why this entire term will become 0 here. So let m equal to n minus 1 minus n or n equal to n minus 1 minus n. Okay. So n is, if n is n plus n minus 1 by 2, then it will be m will become n minus 1 minus n, that is n minus 1 minus n plus 1 by 2. So it will become n minus 3 by 2. If n is n minus 1, then n will become 0. So therefore, h of omega will become sigma n equal 0 to n minus 3 by 2. H of n into e power minus j omega n plus sigma n equal 0 to n minus 3 by 2 h of n minus 1 minus n into e power minus j omega n minus 1 minus n. So therefore, h of omega will become sigma n equal to 0 to n by 3 minus 2 into h of n into e power minus j omega n plus sigma n equal to 0 to n minus 3 by 2 into h of n minus 1 minus n into e power minus j omega n minus 1 minus n, since m is replaced by n here. Okay, so the response, impulse response is antisymmetric. Then h of n minus 1 minus n will become h of n. Okay, so it will become h of omega equals sigma n equal 0 to n minus 3 by 2 h of n into e power minus j omega minus sigma n equal 0 to n minus 3 by 2 h of n into e power minus j omega n minus 1 minus n. Okay, so this will become like this. Then let k equal to n minus 1 by 2 minus n, then n equal to n minus 1 by 2 minus k. If n is 0, then k value will become n minus 1 by 2. N is n minus 1 by 2, then it will become k value will become if n is n minus 3 by 2, then k value will become 1. Okay, so it is equal to e power minus j omega t n minus 1 by 2 plus into sigma 3 equal to 1 to n minus 1 by 2 into h of n minus 1 by 2 minus n into 2j sin n minus 1 by 2 minus n. That is h of omega. Next, here system properties, impulse response, step response, DAT and FFT, circular convolution, difference between analog and digital filters, direct formula. Here we have to discuss these things later. So then the above problem, continuation of the problem is e power minus j omega into n minus 1 by 2 into sigma n equal to 1 to n minus 1 by 2 into 2j 2 into h of n minus 1 by 2 minus n into j sin omega h. J equal to, let j equal to e power j pi by 2. Okay, then h of omega will become e power minus e power j pi by 2 into e power minus j pi j omega of n minus 1 by 2 sigma n equal to 1 to n minus 1 by 2 2 into h of n minus 1 by 2 minus n into sin omega n. So it is equal to e power j pi by 2 minus omega into n minus 1 by 2 into sigma n equal to 1 to n minus 1 by 2 into 2 into h of n minus 1 by 2 minus n into sin omega n. So that mod h of omega is sigma n equal to 1 to n minus 1 by 2 into h of n minus 1 by 2 minus n into sin omega n, and phase angle h of omega is pi by 2 minus omega of n minus 1 by 2, that is beta minus omega alpha. Where beta is pi by 2 and alpha is n minus 1 by 2. So we'll see if n is same antisymmetric, response is antisymmetric, and n is even. Okay. By doing the same procedure, it is in between. The antisymmetry lies between n by 2 minus 1 and n by 2. So same procedure, so that we will get h of omega equal to e power j pi by 2 minus omega into n minus 1 by 2 sigma n equal to 1 to n by 2 2 into h of n by 2 minus n sin omega into n minus 1 by 2. So mod h of omega is equal to sigma n equal to 1 by 2 sigma n equal to 1 to n by 2 into 2h of n by 2 minus n into sin omega into n minus 1 by 2. So mod h of omega, that is mod h of omega, and angle of h of omega is pi by 2 minus omega into n minus 1 by 2. That is beta minus omega into alpha. Here beta equal to pi by 2 and alpha is n minus 1 by 2. So this is about the FIR response for symmetric and antisymmetric. N is odd and even phases. Next, design techniques for linear phase FIR filters. Design techniques for linear phase FIR filters. The well-known methods of designing FIR filters is as follows: Fourier series method, Windows method, and frequency sampling method. Here we have three well-known methods are there: Fourier series method, Windows method, and frequency sampling method. Frequency sampling method. So first one is the Fourier series method. So what is Fourier series method? The frequency response h into e power j omega or h of omega of a system is periodic 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 Fourier series analysis. We know that any periodic function can be expressed as a linear combination of complex exponentials. Any Fourier series analysis. Any function can be expressed as a linear combination of complex exponentials. The desired frequency response of an FIR filter can be represented by the Fourier series. Okay, so it is represented as HD of e power j omega is equal to sigma n equal minus infinity to infinity HD of n into e power minus j omega, where the Fourier coefficient HD of n are the desired impulse response sequence of the system. The samples of HD of n can be determined by using the equation which is inverse Fourier transform of, that is HD of e power j omega. So HD of n equal 1 by 2 pi integral minus pi to pi HD of e power j omega into e power plus j omega d omega. That is equation number 2. So the impulse response HD of n from equation number 2 is an infinite duration sequence. Okay, HD of n is infinite duration sequence. For FIR filters, we know that infinite Fourier infinite impulse response to a finite duration sequence of length n, where n is odd. So h of n equal to hd of n for n equal to minus n by n 1 by 2 to n minus 1 by 2. It is equal to 0 otherwise. Taking Fourier transform of h of n, we get a z transform of h of n, we get z transform of h of n equal to h of z is equal to n is minus n by 2 to n minus 1 by 2 to n minus 1 by 2 h of n into z power minus n. So it is equal to sigma n equal to minus n minus 1 by 2 to minus 1 h of n into z power minus 1 plus h of 0 into z power 0, that is 1. So plus sigma n equal 1 to n minus 1 by 2 to h of n into z power minus n, that is equation number 3. So it is equal sigma n equal to 1 to n minus 1 into h of n into e power z power minus n plus h of 0 plus sigma 1 equal to n minus 1 by 2 h of n into z power minus n. Okay, impulse response symmetric, that is h of minus n equal to h of n. Okay, so that it will become h of z equal to h of 0 plus sigma n equal to 1 to n minus 1 by 2 into h of n is taken as common z power n plus z power minus n. Okay, that is equation number 5. This transfer function of the filter h of z represents a non-causal filter due to the presence of positive force subject. Okay, it is a non-causal filter. So the transfer transfer function h of z is not physically realizable. Transfer function h of z is not physically realizable. Realizability can be brought by multiplying equation 5 by n minus 1 by 2. Here n minus 1 by 2 is delay in samples. Yes, we see that causality is by multiplying the transfer function by the delay factor alpha equal to n minus 1 by 2. This modification doesn't affect the amplitude response of the filter. Okay. However, the abrupt re- the abrupt transfer of the Fourier transform results in oscillations, the pass and the stop bands. So the oscillations are due to the slow convergence of the, particularly near the point of discontinuity time offset, is known as Gibbs phenomena. Gibbs phenomena. Gibbs phenomena for the undesirable oscillations. And this can be reduced by multiplying the desired frequency response coefficient by an appropriate window function. Okay, appropriate window function. So this is about the first one. What is the Fourier series method? Fourier series method. In the next class, we will discuss about the Windows method and frequency sampling methods. Just we will go through this. If you have any doubts, then we'll discuss it later. Okay. Okay, thank you. With this, I am concluding the today's class.